Hello and welcome to A-Level Math. This is the first video in the series Circles, and this video assumes that you have a basic understanding of the coordinate geometry. That means you are familiar with the distance formula, section ratio formula, and also you need to be familiar with very basic concepts of straight lines like the slope of the line segment between 2 points and some of those basic concepts. So I would advise you to please go and watch my previous videos on straight lines and the basics of coordinate geometry. Let's get started with the basics of circles. The equation of a circle with center at the origin and radius r is given by x squared plus y squared is equal to r squared. Now what does it mean? Remember what I told you about equations? Equation uniquely determine or represent a geometrical object. So remember how we discussed the equation of a straight line. We discussed that a particular straight line can be uniquely expressed by its equation. So if we have the equation of a straight line, we can literally tell anything about the straight line, and it's just like every information that is obtained from the equation of the straight line. You can obtain any equation from any information from that equation. Similarly, circles or any other geometrical figures that we'll be going to study in this entire tutorial of coordinate geometry, circles, ellipse, hyperbola, parabola, anything, they all have their respective equations, and those equations literally define everything that you need to know about them. So equation is like the everything you need to know about any particular object. So here we'll be concerned with the equation of a circle. So remember how we used to find out the equation of a straight line? We used to take an arbitrary point. So suppose that I take a circle with center at the origin. So that means my center is over here and the radius is equal to r units. So suppose this distance is r units. So to find out the equation of a circle, what we do, we randomly take a point somewhere. So you can take a point anywhere on the circle, let it be x comma y, and think of this point to be moving. But wherever it moves, this distance, this is always going to be the radius of the circle. So at any point, this x comma y moves. So assume that this point is moving. That is how we think about this point when we are deriving the equation. So, but wherever this point is, it always maintains this distance r with the origin. That means the distance between the point x comma y and the point 0 comma 0, which is the origin, this distance is always equal to r units. So let's see what we get. The distance between x comma y and 0 comma 0 can be given by x minus 0 the whole squared plus y minus 0 the whole squared is equal to, this distance is actually the radius, so this is equal to r. So we get root over x squared plus y squared is equal to r. Now you square both the sides, so you get x squared plus y squared is equal to r squared. And this is exactly what we are given. We are given that the equation of a circle with center at the origin and radius r units is actually x squared plus y squared is equal to r squared. And we have derived it successfully. So now what we need to define the equation of a circle with center not at the origin but somewhere else. Okay, so suppose that this is the center. Now center suppose is h comma k, and this radius is again r units. So again, to find out the equation, what do? We take an arbitrary random point somewhere on the circle and assume it to be moving, but wherever it moves, a distance from the center h comma k is always equal to r units. So it's x minus h the whole squared plus y minus k the whole squared is equal to r. On simplification, this gives us x minus h the whole squared plus y minus k the whole squared is equal to r squared. So this is the equation of a circle with center at h comma k. Okay, so we have proved this as well. So remember that for any equation, whenever you are given the center at the origin, and if you want to shift the origin to somewhere else, just replace the x by x minus h and y by y minus k, where h comma k is your new center. This concept of replacing or shifting of the origin will be used many a times. So always remember, whenever you want to translate a particular geometrical object, translating means just pulling that object and putting it somewhere else. That is known as translation. Whenever you are doing that, and the new center is known to you, suppose it is comma k, all you need to do is just replace that x by x minus h and y by y minus k. So let's take up a question now. Find the equation of a circle whose center is 2 comma minus 1 and which passes through the point 3 comma 6. Okay, so we are given the center of the circle. The center is 2 comma minus 1, so 2 comma minus 1 is somewhere over here, and it passes through the point 3 comma 6. So suppose 3 comma 6 is somewhere over here. It might not be obvious because it's not like 3 comma 6, but anyways, assume it is 3 comma 6, and this is the center. So first of all, what we do, let's find out the radius of the circle, because the distance of the center from any point of the circle is actually the radius. So what we do, we find out the distance, which is the radius. So 2 minus 3 the whole squared plus minus 1 minus 6 the whole squared is equal to root over 1 plus 49 is equal to root over 50. So root 50 is my radius. Now I want to find out the equation of the circle. So what do we do? Let's take an arbitrary point on the circle. Let it be x comma y. So x minus the center, the x minus h, which is 2 the whole squared, plus y minus k the whole squared is equal to r square, means root 50 the whole squared, which is actually 50. So I am removing this root and that's it. Root 50 the squared is 50. So this is the equation of the required circle. Also, if you want, you can open up the squares and further simplify. This will not be k, this will be 1. You can open up the squares and simplify and take the constants on one side, but you can also keep it as is as well. So let's move on to the next question. Find the equation of a circle of radius 5 units whose center lies on the x-axis and which passes through the point 2 comma 3. A lot of information. So let's see what we can do over here. The first thing says that the radius is 5 units and the center lies on the x-axis. So suppose that my center is somewhere over here. So I don't know the center, but it is said that it is lying on the x-axis. So let's assume that it is something of the form a comma 0. Okay, so this distance is a units and we are not climbing up in the direction of y-axis. So this point is a comma 0. There's my center, and assume that this is my circle. This radius is 5 units. Okay, no problem. Which passes, and the circle should pass through the point 2 comma 3. So it also passes through point 2 comma 3. Suppose this point is 2 comma 3. So this distance is 5 units. So this will help us to find out the value of a. So let's do that first. We know that the distance between the center and 2 comma 3 is 5. So a minus 2 the whole squared plus 0 minus 3 the whole squared is equal to r, which is 5. Okay, so a minus, okay, we square both the sides and alongside we also open up the squares. A square plus 4 minus 4a plus 9 is equal to 25. Let's bring everything on one side. A square minus 4a, 9 plus 4 is 13. 13 minus 25 is minus 12 is equal to 0. So you factorize to get a minus 6 times a plus 2 is equal to 0. So we get a is equal to 6 comma minus 2. Okay, so we have two values of a, and that is why we will be actually having two circles. So if we take a is equal to 6, so if this point the center is 6 comma 0, then the equation of my circle will be x minus h the whole squared plus y minus k the whole squared is equal to r square. And if I take minus 2 to be, so if my center is minus 2 comma 0, then the equation of my circle is x plus 2 the whole squared plus y minus 0 the whole squared is equal to 5 square. So these are the required two equations of my circle. So why I'm getting two equations over here? Because there are two circles which satisfy the same property. And that is why I'm having two circles or two equations for those two circles, and I have two circles as my answer instead of one. Maybe possible. Next, the equation of a circle with x1, y1 and x2, y2 as the end points of a diameter is given by this. So let's prove this result. Suppose I have a circle and I am given the diameter of the circle, and I know these 2 points, the end points of the diameter. This point is x1 comma y1, this point is x2 comma y2, and I want to find out the equation of the circle. So what do we do? Let's take an arbitrary point on the circle. That is what we always do to find out the equation. Now let's join these. Now from your class 10th geometry, you must be knowing that this is the angle in a semicircle and hence it is equal to 90 degree. So what is the slope of this line segment? The slope of this line segment is y minus y1 by x minus x1. And what is the slope of this line segment? This line segment is y minus y2 by x minus x2. Now these are the two slopes, and I know that the angle between these two is 90 degree. So from the straight lines slope chapter, we know that the product of their slopes is equal to -1. Let's simplify now. Y minus y1 times y minus y2 divided by x minus x1 into x minus x2 is equal to -1. Cross multiply and pull everything on one side. So we get y minus y1 into y minus y2 plus x minus x1 into x minus x2 is equal to 0. So this is what essentially is given to be the equation of the circle. You just need to replace these two. I mean, transport here and there. 5 plus 2 or 2 plus 5 means the same thing, right? So you just need to put them here and there. That's it. Let's take up a question. Find the equation of a circle, the endpoints of one of whose diameters are these and these. So these are just our x1, y1 and x2, y2. So the equation of the circle is x minus x1 times x minus x2 plus y minus y1 times y minus y2 is equal to 0. You can simplify this and obtain your equation. That's it. Let's have one more question. Find the equation of the circle drawn on the diagonal of the rectangle as its diameter, whose sides are these, and these. So let us first draw our rectangle. Let's assume that these are my x and the y axis. X is equal to 6 is a line parallel to the y axis. We discussed this thing in the last part of straight lines. So x is equal to 6 is somewhere over here. This point is 6 comma 0. X comma minus 3 is again a line parallel to the y axis but in the opposite direction, and this point is minus 3 comma 0. Y is equal to 3 is a line parallel to the x axis, so go something like this, and y is equal to minus 1 is again parallel to the x axis and over here. So these are the 4 points of my rectangle. 1, 2, 3 and 4. These are my 4 points. The first point is over here, the second point is over here, the third point is here, the fourth point is here. Now I want to find out all these vertices. So this line, let me write down again. This line was x is equal to 6. This line was x is equal to minus 3. This line was y is equal to 3. This line was y is equal to minus 1. So if I solve this line and this line to find out the intersection, I'll be getting 6 comma 3, because just x is equal to 6 and y is equal to 3 will be the solution of these two straight lines. Similarly, if I solve these two lines, this one and this one, I'll be getting the point to be 6 comma minus 1. Similarly, this point will be minus 3 comma minus 1, and this point will be minus 3 comma 3. So these are the 4 endpoints of my rectangle. Now I want to find out the equation of the circle drawn on the diagonal of the rectangle as its diameter. So if I take this diagonal, then I'll be getting one circle, because if I take this diagonal and draw a circle using this diagonal, then I'll be getting one circle which will be given by if I take this as x1 y1, x1 and y1, and this as x2 y2, so my equation will be x minus x1 times x minus x2 plus y minus y1 times y minus y2 is equal to 0. This is the equation if I take this diagonal. Otherwise, if I take the other diagonal, then I get these 2 points. I assume that this is my x1 y1 and assume that this is my x2 comma y2. So the equation will be x minus 6 times x plus 3 plus y minus 3 times y plus 1 is equal to 0. In either case, I am getting the same circle. Can you tell me why? These two circles are actually and essentially the same. Can you tell me why? Because assume if I take this diagonal and draw up a rectangle, a circle, then actually this will also be the same circle, because my circle actually passes through all of these four vertices. So these two diagonals are actually the diameters of the same circle, and that is why I'm getting the same circle in both the cases. Doesn't matter which diagonal I take. So it was a good exercise to know that for any rectangle, if you take the two diagonals and draw circles with those two diagonals as diameter, you will be actually getting the same circle. Okay, and let's take up one more question. Y is equal to 2x is a chord of the circle this. Find the equation of the circle with the chord as its diameter. So assume that the given circle is this: x squared plus y squared minus 10x is equal to 0. Suppose that this is my required circle and y is equal to 2x. This is the chord. Y is equal to 2x. This is the line of the chord. Find the equation of the circle with this chord as the diameter. Now I want to find out the circle or the equation of the circle where this chord is actually the diameter. No problem. What I need to do is that I just need to figure out what these 2 points are. And always remember, whenever you want to find out the point of intersection, just solve these things. So all I need to do is just solve this y is equal to 2x and this x square plus y square minus 10x is equal to 0. So let's put down y is equal to 2x in this equation. And now we'll be getting a quadratic equation. And all we need to do is to solve it. So 5x square minus 10x is equal to 0. Take 5x common. X minus 2 is equal to 0. So we take x into x minus 2 is equal to 0. So we get either x is equal to 0 or x is equal to 2. Okay. So I get these two values of x. If I put these values over here, I get the two values of y, corresponding values of y. So y is equal to 0 and y is equal to 4. So my 2 points are, suppose first point is 0, 0 and the other point is 2, 4. Now these 2 points are the end points of the diameter. So I can find out the equation of the circle as x minus x1 times x minus x2 plus y minus y1 times y minus y2 is equal to 0. You can solve this, simplify this and find out the answer. And some more basic questions. Find the equation of a circle with center h comma k and touching the x-axis. Okay, the question says that the center is at h comma k and the circle touches the x-axis. That means my circle is just touching the x-axis, something like this. Okay, at single point, at some point over here, my circle is touching the x-axis. And this is the center of my circle h comma k. Now let's draw this and this. Okay, what can you say about this? This is actually the radius, but this radius is actually equal to k units. Can you think and tell me why? No. Why? Because to reach this point h comma k, you travel h units in this direction and k units in this direction, right? So this distance is actually k units, but this is actually also the radius of the circle. Okay, so this k units is actually the radius of the circle. So if I take this center to be h comma k and the circle touches the x-axis, then this k itself becomes the radius. You know why? Understood? So my radius is here k units and the center is h comma k. So the equation of my circle is x minus h the whole squared plus y minus k the whole squared is equal to, instead of r square we have k square, right? So this is the equation of the circle. Next question, find the equation of a circle with center h comma k and touching the y-axis. So let's again draw the stuffs, and this time the circle touches the y-axis and this is the center. Suppose this is h comma k, and if you join this, then what is this? This is a radius and this is equal to actually h units. Why? Because to reach this point you travel h units in the x-axis and k units in the y-axis. So these h units are actually both h units. So this is also h and this is also h. So this radius is actually h units. So I have the center equal to h comma k and radius as h. So my equation of the circle will be x minus h the whole squared plus y minus k the whole squared is equal to h squared. And the last question, find the equation of a circle with center at h comma k and touching both the axes. Interesting. So my circle now touches both the axes. Okay, I'm sorry because it is not touching it, but anyways we'll manage. So I assume that it touches over here. Okay, now it is also making a chord, but anyways assume that it touches it over here and x-axis over here, and this is the center h comma k. So this is the center h comma k. Now this is also the radius and this is also the radius, and this is k units and this is h units, because to reach this point you travel h units over here and k units over here. So this distance is h and this distance is k, and this h and k are actually equal because they are both the radius of the circle. So let them be equal to r. So my center actually becomes, instead of h comma k, I can replace everything with r. So my radius is r and my point is r comma r. So my equation will be x minus h, which I can replace with r the whole squared, plus y minus k, which I can replace again with r the whole squared, is equal to r square. You can simplify all of the equations that we have discussed to get the answers in a simplified version. You can try it at your home. And that's it. Thanks a lot. We'll be taking up, this was a very basic video covering some basic concepts of circles. We'll be taking harder problems in the videos to come. Stay tuned with A-level math. Thanks a lot. Study hard, study smart. Bye-bye.